Find f dashed x if f of x equals the integral between 1 and x of cos cubed t dt. So the hardest thing with these, especially if you get them in an exam condition, is to just stop yourself from sort of automatically trying to sort of integrate that thing with respect to t. So if you look at it, we have f of x and we want f dashed x, so that means we have to differentiate. But if you look at what we're differentiating, it's already an integral, so already you should see something is wrong. And also you've got t's in the function and you've got x's in the integral bit, so it's certainly very unfamiliar as far as just looking at something that you integrate. This is all about the fundamental theorem of calculus, which says if f is continuous on the closed integral between a and b, then it says d over dx, so the derivative with respect to x of an integral between a and x of f of t with respect to t equals f of x. That would work for any x in the open interval between a and b. So if we look at what we've got, we have f of x equals the integral between 1 and x of cos cubed t dt. So we've got our f of t dt, so that's fine. We have an x and we have an a. Well, a is just 1, it's a nice constant, so everything is already in place. So by the fundamental theorem of calculus, our f dashed x just equals f of x, so it's literally just cos cubed x. And there's nothing else we need to do. Now we could say, well, is this valid? And yes, it is valid, because if you think about the f as in the cos cubed t, well, that's continuous everywhere, because well, cos t is always continuous. There's never a place where it's undefined. So this is going to be valid on the whole interval.